Okay. Well, okay, we are compiling and running. What are the to-dos? Okay, I don't know about that one. Okay, well, this one. I think the answer to that is yes. So maybe I should do that. The transparent border thing, I'm leaning towards keeping it that way, so it's probably fine. Get from assets, temp collision lines. Oh yeah, well, we need to pull that out somehow. Should world space be bottom up? I don't know. Although, we'll see. Alt tab, we don't need that right now. Handle grounding. Collision does not handle mirroring well. Actually, it kind of does now. So let's remove that. Only when grounded. Yeah, well, we're not really handling grounding, so let's keep that. Special clips to draw as sprites. Yeah, at some point. Temp code to draw collision lines, temp string, collision shape. Okay, well, alright. So, should flip lines be halfway through collision shape? Let's do that. I guess let's start here. Flip line. Okay, so this is really where it happens. Game assets, entities, flip lines. Yeah, so what we can do here is we can just pull out collision, because we just have a collision rectangle there, right? Collision. There we go. Rect collision rect is that. And then flip lines would just be collision. Yeah. And then, yeah, there we go. And flip lines would just be halfway through that. So, so collision rect has an offset relative to the top left of the reference sprite. So I believe what all we need to do here is rect flip lines. Well, actually we don't even need that. Actually, we can just do that. Sprite rect flip lines is something like what collision rect top left plus half dim. I think that's all we need. So it's v2 add collision rect top left. Should I have generic functions for these things like add? Maybe. Collision rect top left and then v2 scale. Collision rect dim 0.5. Yeah, so just that. And then there we go, it's the same as it was before. And that's all we gotta do, really. So then we can just go, well, we can go into the art and remove that from the art. So this flip line thing, we just delete layer. And in here we have the flip lines and we just delete layer. Save. So alright, so now we just have the collision. Yeah, we have the collision and that's it, that's all we need. So in the build program, then anything to do with flip lines just goes away. Wherever. Okay, so flip lines, I think, yeah, it's just everything from here down. Okay, so that's not a thing anymore, so layer info, let's just remove flip lines. Yep, is flip lines, so that can't happen. Okay, found flip lines. We cannot find flip lines because we don't have them. We don't need this, and that's not a thing either. So there we go. Okay, now just all these unused. That's not needed. That's not needed. Okay, are we good? I think we're good. Yeah, right. Focus into primary. Yeah. Okay, removed it here. Yeah, so that's all the flip lines being removed. Yep, just flip lines got removed. Yeah, that's not true anymore. And the art got edited. Alright, so make flip lines be halfway through collision. There we go. Okay. Well, now what? Yep, yeah, okay. Oh yeah, we need to actually get the walls out of somewhere. Yeah, so that one. Get from assets. Yeah, that's fine. Okay. So what are we doing even with the walls, with the stages? No, are we doing anything? Okay, we are reading them. File info stage, yeah. Okay, so right here. If it starts with a stage, then we do all of this stuff. We have an index in the way, and then we just keep them here. Yeah, so we're not doing anything with that information. Interesting. Well, let's look at it. So that is what the stage is. So right now it's just got this one line down the bottom, and that's it. And of course the coordinates here are top down. Like this is 1,000. Yeah. Well, we'll see. That's an actual problem, I suppose. So there you go. We have a stage. Now just to read that stage. Well, actually, you might as well draw stuff here that's that is representative of all the things that we'll have. And so what happens outside of bounds? Is it... I guess it's just a solid fill. I mean, I suppose if it is a solid fill, then you don't really need to draw a border or anything. So, let's remove that. I suppose you can select. Yeah. Yeah. Alright. What did I want to do? I wanted to draw something that would be representative of some walls. I just need some walls. Oh my god. Oh, what? Ah, there we go. just replicate the walls that we already have and call that a level. Why not? Alright. And now this needs to be pulled out. Because it's a stage, this needs to be pulled out. I mean, I suppose not everything in the stage will have collision, but for now, let's just say that everything in the stage has collision. And yeah, like looking at these coordinates, it's like 89, 70. And it'd be nice to just be able to like place. Although I guess I can always just have a function that does that. Yeah, I suppose it's not that hard to just write a function that says like, oh, place at a sprite coordinates, and it just flips the y. But then debugging, well, I suppose debugging isn't. They will be in bottom up for debugging purposes. But I don't know, that's might be better. I don't know, because it's more intuitive for physics and stuff. Alright, so there's the level, and now oh, maybe expert coordinates should just be world coordinates. Maybe not. Anyway, so given this level, let's read that in. And I guess the way we're gonna handle this is like, what is this? Is this one wall or is this multiple walls? Or is this like 4 walls? Like should this have collision? And this? I mean, I guess so. Because normally you draw something like this, right? Like some kind of a shape. But then internally it wouldn't necessarily have collision. So like if this was a shape, then you'd kind of expect all sides of it to have collision, so then why would this be any special, like any different? Might as well put collision on all of the edges here, like we can do that. Of course, how exactly are we gonna do that? Like, well, alright, so here's some rectangles. Okay, whatever we draw, it can always be represented as just rectangles. Like any shape that's supposed to have collision. That is just a series of rectangles, and each rectangle is like 4 walls, essentially. So, I mean, I suppose we can start with just the one rectangle and just get that working. Okay, so when we scan this, what we're gonna find is some offset, right? Which will, well, the offset will tell us where the collision is, essentially in world coordinates. So that'll let us place this thing in world coordinates. And then what? And then we're gonna have to scan, I guess, the pixels, because it's not always gonna be right. So we're gonna have to scan the pixels and somehow find all these corners and connect them together into a wall, into a set of walls. Actually, speaking of walls, how are they being represented now? Let's see. Okay, so they're represented as like type plus left plus like the reference point plus length. So I don't reckon I'm gonna change that. Where is this? It's not common. Yeah, so I'm gonna change this. Oh my god. So really what we need with walls, collision walls, is we just need 2 points, and the order of those points can essentially encode what direction the wall is supposed to be blocking stuff from. So like this point goes to this point, and it's like what, I don't even, like, it's clockwise means up, and so here you would go from here to here. So although wait, it's just the 2 points. Now given that it's only the 2 points, well, I guess you could say, well, from this pixel to this pixel, if you draw a vector and rotate it in the xy plane 90 degrees, you get the normal. So then here it would be draw a vector and rotate in the xy plane. Yeah, so if this goes from here to here, you'd get that. If this goes from here to here, well, from here to here, and you rotate in the xy, yeah, you'd get the correct result. From here to here and the xy. Yeah, so 2 points. Each wall can be represented as just 2 points. And that's it. And even diagonal walls can be represented as that, not that we have diagonal collision shapes. But yes, from here to here, and then rotate in the xy, normalize, and you get your normal. Yeah, and what about oh my god, what happens with like this kind of shape? I mean, I suppose it still kind of works. You get from here to here and rotate in the xy, and you get your normal, which is from here to here and rotate in the xy, which is, yeah, so that it still works. Just the question is, how do we actually walk around this? Alright, well, first of all, the part that I know how to do is to change this. V2, I guess P1, P2, just the 2 points, there we go, and the order encodes the, alright. Okay, well, this is gonna, alright, so we're gonna remove all of this. Okay, so it's not really left, top, or whatever, this is just P1, and then length isn't length. Okay, so what this is, really, alright, what this is P2 equals something. Alright, so this first one is minus 100. Okay, this is just minus 100 minus 40. Let's actually remove most of them, I decided. Let's keep it to minus 100 on the x, and then instead of being minus 40, let's make it 40 on the y. So this should be vertical. And it goes from minus 40 to 40. So if you draw a vector and then rotate it in the xy, so the normal should point to the right. Alright, so what do we got here? Yeah, alright. Collision wall unit vector. Okay, so collision line is this thing. Okay, so this collision line type count thing, that's not... yeah, that's not the thing that exists anymore. Okay, wall normals, wall unit vectors, and wall shift. No, wall shift is to allow for rectangles, that's right. Okay, so wall normals... alright. So this needs to be reworked. So wall bound 1. I mean, it's essentially P1, but it's a little different. So wall bound 1 is P1, but we need to move it, well, alright. I think we need these two things first. So wall normal would be a vector between P1 and P2, which is V2 sub collision line P2 collision line P1. Okay, so that's the wall vector. I should actually have it be a wall vector. So that's the wall vector. Then wall unit vector would be that, but normalized. V2 normalize. So wall vector is that, wall unit vector is that. Wall normal is actually the wall vector but rotated in the xy plane 90 degrees. How do I want to write that? V2 rotate, I guess. V2 rotate, what are we rotating? We are rotating wall unit vector. Yeah, just to keep it normalized. We are rotating wall unit vector, and in the x, well, there's only one plane, so in 2D, and y by 90 degrees, which is a quarter turn. I mean, I suppose you can also rotate in the xy, in the yx plane. That's also an option. V2 rotate. And I guess we can just make it implicit that we are always rotating in the xy. 90 degrees is a quarter turn, yeah. Okay, so we don't have these functions, but we will. Now, wall bound 1 would be like this first point. So instead of collision line left, it would be this first point plus wall shift. Okay, so wall shift, that's collision related. So when we're colliding with a rectangle, what exactly is the shift? Let's see. Where is my collision stuff? Here. Okay, so when we're colliding with a rectangle, so we have this point that's in the top left, and the wall shift, so like, so this would be point 1, this is point 2, P1, P2, and that's the normal, because if you draw a vector and rotate in the xy by 90 degrees, then you have this whole vector, yeah. So what's the shift? Well, what do we collide? The current position. Current position is the top left of the collision shape, collision rectangle. So the wall does not need to be moved, so if the normal points to the right, then it does not need to be moved. It's just this first point. Okay. Yeah, it's just the first point that needs to be moved up. Whereas in this case, it's this point, which again is gonna be P1, P2, rotate in the XY, yeah. So it's, again, the first point would need to be moved to the right. And that's it. In this case, the wall needs to move to the left and also up. But otherwise that's it, and the bottom one will be like that as well, so it needs to move up and also... Well, no, it's actually this point that needs to extend. Huh. Interesting. Okay. So what are we actually doing here? Let's yes, rotate this thing. Oh yeah. Yeah, this would need to extend. Well, I mean, I suppose I can just copy that and make it red. And this would need to extend up. By the rectangle size. Yeah. Okay, so it moves up. Okay. Well, we got the rectangle. We got the dimensions of the rectangle. We've got the normal, which is always going to be just 0 in one of the dimensions and 1 in the other. So the shift is you kind of follow the normal by, well, you follow the normal. I mean, if this was in the center, I guess it would be a little easier, because then everything would kind of move homogeneously. Like this would move by half dim, this would move by half dim, this would. But even with the top left, I think this should still work in the same manner. Because the shift is you just move both points along the direction of the normal, but you need to scale that normal by either 0 or the appropriate dimension. Yeah, so you dot the normal with the dimensions, right? So that'll have to happen. If you just dot the normal with the dimensions, and what do you get out of that? Well, if the dimensions, both the dimensions are positive essentially, so it's like that. So when you dot the normal, you get, because it's a unit vector, you get just one of the components. that? I mean, I guess if you clamp it to 0, like if you make the normal, the dimensions be positive, you sort of go from here to here, then once you dot the normal, like this normal dotted with that, maybe I should, oh my god, why is the arrowhead so big? Well, anyway, so if that is the dimensions vector, isn't negative on the x and positive on the y, then this dotted with that will be negative, so you clamp it to 0. But this dotted with that is just this dimension, so you move it. This dotted with that is negative, so clamp it to 0. This dotted with that is the dimension. So that is the shift, but there is also the extension that needs to happen of the wall. And the extension is what exactly? Well, oh my god. So this, 6, this gets extended by the size of the rectangle up like that. And this gets extended up, and that's it. This gets extended to the right. And then this gets extended to the left. Yeah. And that gets extended like down. Oh, up as well. Yeah, that seems correct. Huh. So this, interestingly enough, gets extended to the right. Wait, did I extend it right? I don't think I did. No. No, it does get extended to the left. Same as that. Yeah. Alright, well, they are kind of uniform in how they get extended. So we kind of know what this distance is already. It's, well, if we take the wall unit vector and dot that with the dimensions, then for the vertical ones, for the vertical walls, we do get the correct extension. For the horizontal walls, actually we also get the correct extension. Like, yeah, we'll just follow the unit vector by that amount. Except that what are we going to be adding that to is the question. Because this is P1, P2. This, like, they go this is P1. This is P1, P2, draw, and then rotate in the XY. Wait, no, this is P1. This is P1, P2, so they would go in the opposite order because that's where directionality is encoded. The P1, P2, draw a vector, rotate in the X, what? So it's the opposite actually. This is P1. If the snapping could go away, that would be pretty good. So this is P1, P2, but no, this is actually P1, and that's P2. P1, P2, and then rotate in the XY plane. Okay, P1, P2, and then rotate in the XY plane. Yeah, like that, rotate in the XY. Got that, rotate in the XY. Got this, rotate in the XY, which is clockwise. Okay, so that means that an anti-clockwise rotation should get us the unit vector. Yes. Yeah, that's anti-clockwise, right? Yeah. So in this case, it's the P1 that's getting added. In this case, it's the P2, which is kind of probably not exactly what we want here. Well, we do have a unit vector and a normal and one of the points, right? So we can always just, after getting the unit vector, the normal, and one of the points, we could just reconstruct the second point. Later. So the shift is a dot product of the normal with the dimensions, and the extension is the dot product of the unit vector with the dimensions. But what, like in the case of this wall, P1 needs to be extended, but in the case of this wall, it's P2 that needs to be extended. I mean, I suppose if we take wall bound 1 to be either the leftmost or the topmost, like it doesn't have to be P1 or P2 because we already have the normal and the unit. So at this point we can just pick one of these points, which could be the left or the top. And then just modify it the same way we modified it before. And then reconstruct the second point from that. Like we know what the length is. Anyway. Alright, so I'm gonna do that. But for now I'm gonna go take a toilet break. Okay. Alright, well, let's do this then. Of course, I need to figure out which one of these is the top or the left. And like, well, how does that work in general? It's like if you have a line, well, has the smaller x. Well, I mean, I guess if you bottom up, top down, like normal coordinates, this has the smaller x and the bigger y, this has the bigger x and the smaller y. So neither of these is really... Yeah, neither of those is really the top one. So like, it's just out of curiosity, like, what would happen here? I mean, you do need to like shift the wall up. By, well, up by the dimension. In order for the collision to work correctly. So if you just take this normal and dot it with the dimensions, what you're gonna get on the y, you're gonna get a positive number, but not quite 1. And on the x, you're gonna get, well, in this case it's gonna be like a negative number. Huh. So maybe that's not actually what you want. Because presumably whatever it is that we do, it should also work with diagonal walls. Not that we have those right now. But there's no reason why like it shouldn't. Like it should be special cased for... So with this wall, I guess you would just move it... I guess you would just move it up. Like that. And then the collision just kind of works without any need to extend it or anything. Well, actually, no, you would need to. Well, I mean, our walls have directions, so no, this would also count as a collision. Yeah, it would be like, except, huh, interesting. So everything up to here just works with a simple shift. But then you'd need this like extension almost to the wall that's actually not in the same direction as the wall. You need to add a little piece here. Which is that, interestingly enough. So it shifted up, and then also to the left, and then this would be allowed. Huh. So it's like the upshift. Okay, and what if we were colliding with the center? What would happen then? If we were colliding with the center, then the wall would need to be shifted up halfway, right? Like that. So that the center collides here. Well, I mean, yeah, so that this, well, actually, it would also need to be kind of extended if we're colliding with the center, because there's no center here, so you would need to break that into two halves and essentially do this. And then, okay, so now the center collides here, so that's not allowed. Except that, okay, you know what, let's remove that, and let's just put a little rectangle in the center. Just call that the center. Okay, so if the center collides, with the modified wall, now it's inside. Yeah. So now that bring forward, bring to front, send backward, send align left, send horizontally, line right, bottom, vertically, top, duplicate, delete, group selection. I see. Well, anyway, so the center collides here, so that's correct, but then that kind of isn't. Okay, so the whole thing needs to be further away, seemingly. Actually, do we just move the wall by... oh my god. Maybe we don't need these so much. Maybe we just move the wall appropriately and then it just works. Let's see. Well... no. Like, at the very least, this needs to extend out to here. But then not down there, really. It's like that. Because it's still shifted to the left. Okay, so now this is what the center collides with, for the corner specifically. But then... okay, well, there's no collision here. What's going on? So this is... I mean, this is still a collision, though. Presumably. So, like, it should extend, like, all the way to here. I mean, okay, let's try it. So, like, alright, so that. So that's what the center collides with to make this work. And this is essentially the size of the rectangle, right? And then you can pass through once you pass here. And presumably you're gonna have something like that going on at the top there as well. Except this time it's like the other side of the rectangle. Well, all the way up to here, actually. Okay, so this is actually, yeah. This is just the shape you get if you take the center of the rectangle and just kind of sweep it across the wall. So that's what you need to be colliding with. And then you can do point collision on these three walls. So really, each wall is three walls. And I guess if everything's referencing the center of the collision shape, then it's a bit more uniform. And, well, I mean, you can also fill in the other two sides, theoretically. There, so each wall is actually this shape for the purposes of collision. If we can collide with it from all sides, then each wall is that. And then, well, that's for walls where collision works from both directions. For walls, our walls are kind of directional, so these are not really appropriate. Okay, so these would be collision lines, but only if we were colliding from both sides. So really that's what we need to construct, and that's what we need to collide with then. So, well, I mean, this initial, it's like if we just follow the wall normal, so that's the wall normal. So if we just follow the wall normal by half dimension, so assuming that we have, so if we just take well, actually, is it half dimension? Okay, I drew it at kind of a 45-degree angle. But presumably this just kind of works for no matter what the orientation is. Well, actually, no, it wouldn't. No, it wouldn't. It would work only for a specific orientation. Actually, what does it look like for a different angle? Like that. Well, presumably we just do the sweep. Oops. So do the sweep. And then... okay. Nope. 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 Is it here? Right, that'll do. And then do the sweep like that. And then just connect them. Just connect them up here. And then when this collides, yeah, so do the center collision with this. No, actually this is not quite correct, so no, this would go, yeah, this would go only to this corner. Yeah, essentially to that corner, and then it would go there. It would go horizontally like this. Yeah. Okay, so that's what it looks like for this wall, and that's what it looks like for this wall. So it does look like the wall just moves up, following the normal, and then we have two extra walls where one of them is sort of vertical and one of them is horizontal. But then, well, the vertical and the horizontal walls, those kind of assume, well, this vertical wall especially, that assumes that we're doing side-on collisions. Because for a fully aligned wall, what we have is just a move up and then the two, well, actually, well, oh, because if we were doing side-on collisions, then, well, this is just a move up. This is a move up, and we need to make it like bigger by half dimension like that. And then for side-on collisions, you would also have sort of this wall. It's like an additional wall that gets added. Oops. And then same on that side. Yeah, and same here. So in principle, it's like, it's not that different. Of course, is this, hold on. Yeah, that seems to be the same size, but this would be, this would be bigger. Oops. Yeah, this seems to be about the same size as well. Well, unless of course we view this as extra walls, in which case well, one of them is oh yeah, because if you follow the same procedure and you just sort of pay attention to one of the corners, like here, this corner, then the actual sweep would go from here to here. So this would go to here. And then this is actually an extra wall that's in here. Like that. Okay, so now these are all equivalent now. Okay, so this did get moved up. And it almost seems like it's moving up by like the same angle. Like no matter what. Which kind of does make sense. I mean, it is this angle, right? Because that's what I did. So we're not really following any normals here. We're just literally taking this vector and moving both points by that. And then adding 2 extra walls, where one of them, well, so if you want to allow side-on collisions, then yeah, you would add 2 extra walls. Of course, maybe we should just have all the walls work like this. Oh, but then, like, or at least prevent side-on collisions. Like, maybe you should be allowed to pass through here, because even if it's a slight angle, it already kind of doesn't make sense to not have this wall here. I mean, but then again, if you don't have this wall, then you're allowing side-on collisions from the other direction, which is also kind of strange. And I suppose the only way you would collide with the wall, but then again, you're going to be doing a lot of collision detection with collision lines that you can't really collide with, assuming you have a valid world space position. So so like really, even if, oh my god, to make it work exactly the way it works now, even this wall is kind of spurious. It's just these two that we are adding. So move by half dimension, so that's with the center. So move by half dimension, and then just add a wall for but then this wall is going to be collinear, right, with the... Okay, so okay, anyway, so this is how it would work in the general case for any wall. And you can make the decision which walls to add and which ones to not add. So if you only move the wall, then you will be doing side-on collisions, like you will be allowing these kinds of moves. You will only be disallowing these kinds of moves. And then if you do the 3 walls that are like the mirror image kind of the first 3, then that will be a bidirectional wall, and if you don't have those, then it will be a unidirectional wall. So that's the general case. We don't really have the general case here, because all our walls are axis aligned. And not that we encode them as 2 points, because that's probably the easiest when it comes to pulling things out of art. Just pull out the 2 points and have their order tell you what exactly you're looking at. Well then, we can just do what we did before for these axis aligned walls. Is we could just say that's the wall vector, that's the wall unit vector, that's the wall normal. Actually, instead of being for now, let's just do x, y, quarter turn. Let's just do that. Instead of doing general rotation. So now we have unit vector and the normal and the bound one. Maybe I should just do this wall min bound. Just call it, yeah, I call it a min bound, and just say v2 min, which is gonna be I mean, it's not gonna work in the general case, but it will work for our walls specifically. Oh, I guess let's just call it bound 1. Well, bound 1 or OG. This is the OG bound 1. And then wall bound 1 will be, we're just gonna take that OG bound 1 and then we're gonna shift it. By the wall shift. So, okay. What's the wall shift? Well, the wall shift is something like the rectangle. I mean the wall normal. So right now we're looking at min. I mean, let's not go. Yeah, but bound. So this is in world space, right? Which is y up. Y goes up in world space. So the bound that I'm looking for is either the top or the left. So, I mean, I guess if we just shift both points by the dimension, well, I mean, we can't really do it by the dimension, but I mean, well, in this case, you'd get the back wall situation. If you dot the okay, if you dot the normal with the dimensions and then clamp it to 0, then you'll get that shifted wall. But then you have to modify one of the points. So every wall gets extended. That much we know. It's just in which direction. Well, I mean, I guess if an anti-clockwise P1, P2 anti-clockwise, wait. P1, P2 anti-clockwise rotation. So XY rotation is an anti-clockwise rotation. From X to Y, anti-clockwise, yeah, so clockwise should get us so that's the vector going down, the wall vector. We should draw it. So there you go, so there's the wall vector going down. Now, of course, it's going to be the opposite in this case. Yeah, that's the whole issue, really. Oh, what? Okay, so the wall vector goes up here. And then it goes down. And no matter what we do, yeah, the general case isn't really gonna work quite as well. because of all those side-on, like all those spurious walls that we don't really need. And it's also gonna, like, the general case is gonna create extra walls. We don't really need to be creating extra walls because we know the XSL line. So we just need to extend the existing wall. Well, if we, well, okay. So this is not a v2 min situation. This is something else. And as for wall shift, well, it is normal dot. So it's v2 dot wall normal with the dimensions vector, but like the dimensions vector needs to be doctored a little bit. So it's collision dimension x, like it's actually minus x. Like it's minus x, and then it's well, y up, so we need to, so if the wall normal is 0, 1, then it needs to produce a positive, so it's a positive y. Collision dim y. Okay, so there. So it's a wall, it's a dot product of the wall normal with the doctored collision. So because if this is -1, 0, and you dot it with this, then you get a positive number. Well, sure, you get a positive number, but then you're moving the wrong way. Because this shift is negative. So if you dot with just the normal, then you're gonna get a negative number here, but that's kind of what you want. You get a positive number here, that's not what you want. You don't want to be moving this by the dimensions. That just doesn't. Of course, we could collide with the center. In which case, if we're colliding with the center, it's a little bit easier for us. Because then, okay, well then we could just move everything. Well, we can't just move everything though, because here you'd need to move it to the right. Here you need to move it to the left. So the wall normal still matters. Well, I suppose you'd move it to the left and to the right. But we have here these unidirectional walls. It's a little different. So if you move both points that way, well, except that you wouldn't really, would you? Yeah, I mean, of course, yeah, now general collision is not really what I'm looking for. Yeah, so either, whatever you're colliding with, it's gonna be kind of an issue. Well, I mean, the dot product of this and this is positive. Which means that you shouldn't move The dot product of this and this is negative, which means you shouldn't move. The dot product of this and this is positive, which means, oh my god. What? Yeah, because here we would add, but here we would subtract. Maybe we should collide with the bottom right instead. Or like bottom left, perhaps. Because top left. Because if we are colliding with the bottom left of the collision shape instead of the top left, if it's the bottom left, and we're bottom up in our world space, well then this wouldn't move, but this would, right? So it's like, if we just have this collision shape, I mean, if this, yeah, so clamp to 0. So basically, if whenever you're subtracting, whenever the dot product is negative, because right now it's like, well, the dot product here would be positive, like whichever dimensions specification you take. Positive, no. Positive, yes. So yeah, I think that's the main issue. So if we just collide with the bottom left instead, then I think that goes away. Then you just take this, move it over here instead. Bottom left, so like that. Bottom left. I mean, it should be like further down. What? No, don't. It's just so annoying, this auto snapping it's doing. Yeah, so approximately that way. So bottom left means, yeah, we do need to extend it out this way. Oh, there you go. So you extend it out this way, but then this needs to go down, presumably. Oops. So bottom left collision just works. Bottom left collision works. Bottom left works, yeah. And bottom left here also works. Let's extend it this way. Yeah, bottom left, yeah, there we go. Alright. Okay, so you move the wall. So now if the dot product of the wall and the dimensions, if they're both positive, is positive, you don't move. Here it's negative, you do move. Here it's positive, you don't move. Here it's negative, you do move. So if it's negative, then you move it. So you just clamp all the positives down to 0 and move by the negative. Okay, so now at least that's uniform. Alright, well, let's do that. Okay, so current position is sprite common top left plus the collision shape top left. But then I want to add again collision dimensions. There we go. Oh, well, actually not the collision dimensions. Current pos y so that's the offset. Actually, is our offset... What on earth is our offset? Is it top down or bottom up? Oh my god, at what point do we switch to bottom up? Well, it's offset from the top left. It's what you add. So the offset is just what you add to the top left to get to the collision shape. Do we actually do this? Yeah, we do it here as well. And oh fuck, oh my god, what is that? I mean, right now it's 0, of course, so it's like, yeah, right now on the Y it's 0, so it's kind of working. But that's, oh my god, that's the thing. That needs to be consistent. No, it is top down, isn't it? Oh, fuck. It's a top down offset. And right now we're not noticing that because it's 0. Well, it makes sense for the offset to work this way. Maybe we're encoding it incorrectly, but it does make sense for it to work this way. Where you just add to the top left, and we just assume that it's encoded as such that that works. Now, but the Y, God, the current position Y we need to go down by the collision dimension. And going down in world space means you'd subtract. Subtract the dimension, so that would place the current position to the bottom left of the collision rectangle. I guess I need to put it to do here. Is collision offset bottom up or top down? Whatever it is, it needs to be something we can just add to the position. So really top left is like the offset, it's the relative top left. Well, at least the dimensions are clear. So you go down by the dimension to get to the bottom left. Now once you're in the bottom left, maybe you know what? Maybe everything should be bottom. So I mean, maybe everything should be all the way until rendering. I mean, in the rendering, you'll still have to flip stuff around. It's not like it's gonna help that much. You're still gonna have to flip between the two of them at some point. Nah, whatever. Yeah. Okay, so now the wall shift. It is the wall. It's the wall normal dotted with the collision dimensions. But like you only move by the negative. So So the maximum value in either dimension. Wall shift x is max. Wall shift x and except min, and same with y. Okay, so that's the wall shift. Oh, actually, yeah, it's... Oh, well, I mean, that makes it a little easier then, because it is a number, isn't it? The dot product is the number, and then we just do, well, make sure it's negative. So like here it will be negative because you need to go down, here it will be negative because you need to bottom left, because you need to go to the left. So wall shift clamped is min wall shift 0. Okay, so wall shift clamped is that. Now v2 wall shift vector is v2 scale wall normal. I mean, not normal. No, it is normal. Wall normal by wall shift clamped. Okay, so now bound 1. So bound 1, I mean, let's just say that it's P1. And then, like, if collision line P1x is greater than collision line P2x, then take P2, and same with y. So like, because we want, which bound do we want actually now that we're doing bottom left? Well, P2 gets extended, P1 gets extended, P2 gets extended, P1 gets extended, P1 gets extended. Yeah, so not... well, bottom gets extended and left gets extended. Bottom and left. Left and bottom. Okay, so what? At least there's some uniformity there. So if the x is lower, that means it's the left one. If the y is lower in world space, that means it's the bottom one. Okay, so this is just us figuring out wall bound 1. Okay, so if that's lower or okay, so really it's just this expression. Let's wrap it. Okay, so if the x is greater or the y is greater, then accept P2, otherwise accept P1. Okay, so now wall bound 1. There. That's what wall bound 1 is. We just add to the bound 1 OG the shift. Like there. Okay. And then wall bound 2. Well, wall bound 2 is this thing. Length. We could, of course, just do this again. Unless... So bound 1 is either the bottom or the left. And it's always bound 1 that gets extended, right? So maybe... Yeah, you just shift it. By the shift, and then you just extend it by the extension. And bound 2 you just don't do anything with. Shifted by the shift, extended by the extension. And we know what the extension is. It's this v2 dot of the unit vector and the collision dimensions. Yeah, unit vector by the collision dimension, because that always gets... Actually, in this case, it's not even... We don't need an absolute value, do we? Or do we? Well, we kind of do, though. Yeah, because we need to multiply by the whole unit vector. Yeah, so we dot the unit vector with the collision dimension, and we take the absolute value of that. And then we scale the whole unit vector by that amount. But it's already kind of scaled by that amount anyway. So maybe we actually don't do that. Well, the unit vector is always pointing away from P1. So we actually need the negative. We need to negate it and then add that. We add the negative, so subtract. From P1, subtract whole unit vector scaled by the dot product of itself with the collision dimension. You know, we kind of already, well, no, we did the dot of the normal with the collision dimension. Yeah, this is gotta be, alright, well, let's just follow this for now. Let's see, V2 wall extension, I guess. Wall extension is V2, extension, really? Well, yeah, I mean, I guess it's bound one that gets extended, specifically, not bound two. But then you kind of need to know what the bound two is. Oh, God. Yeah, maybe this is not actually the better way. Maybe the better way is to just do what we did here. We just need the length of the line. F32 collision line length is V2 length wall vector. Except this isn't quite right? Well, it could be. Could it? And well, not really, because bound one actually is the thing that needs to move, and not bound two. It's bound one that needs to move. Specifically. Because we're doing the collision with the bottom left. So it's bound one that needs to move. So we need to have worked this out prior. Yeah. V2, I mean... V2 add bound 1 shifted, V2 wall bound 1 is V2 add wall bound 1 shifted, and we're adding the extension, so wall ext. Wall vector, wall unit vector, wall normal. So that's all fine. Wall shift, clamped, wall shift vector. Wall extension. I mean, wall extension is V2 dot wall unit vector collision. So like from P1 to P2, so that would be positive, that would be like negative. would be negative, that would be, well, P1 to P2, this would be positive. I mean, if we're gonna have some if statements there anyway, then perhaps what we should do instead of having this bound one situation, what if we just do this? Wall shift is this, and wall unit and wall extension is that. And then, well, if wall shift is negative, well, actually wall shift specifically, yeah, wall shift is applied only when it's negative, and it's applied to both P1 and P2. So doing a min here actually kind of works. And then we can just apply both of those, apply that to P1 and P2. It's the wall extension. So when the wall extension is negative, then we need to apply it to P2, otherwise to P1. And maybe that would just be better. Because either way, I mean, you either have an if statement here, or before that. Well, not that it makes it that much better. So just like right here, we can do V2 wall bound 1 is collision line P1, V2 add P1, and what are we adding? We're adding the wall shift. And same with 2. So there's bound 1, bound 2. So we don't actually need this, and we don't need that. Okay, so there we go. So we've shifted them, and then there's the wall extension. If wall extension is positive, that means P2. No, negative means P2. Negative means P2. Yeah, P1. If wall extension is positive, then wall bound 1 V2 wall extension vector is what, V2 scale wall unit vector by wall extension. Wall bound 1 is wall bound 1 is V2 add wall bound 1 wall extension vector. else it's wall bound too. I mean, I guess this would be like literally what happens. So when it's positive p1 to p2, p1 to p2, that means it's positive. So add to bound 1, add to bound 1. Except are we adding or are we subtracting? So wall extension is positive. Okay, so wall extension is positive. There is the wall unit vector. We dot it with the dimensions. We get a positive number. We scale this by that amount. Now we need to subtract. It's actually a sub. A sub here. Temp code to draw collision lines. Yeah, I mean, we do kind of need that. Collision line. Okay, well, we don't actually know what the top left is from just that. So that's not good. Well, actually it's that if statement, right? It's like collision line P1 x is smaller than collision line P2 x, or if collision line P1 x is smaller or P1 y is smaller, then it's P1, otherwise it's P2. Yeah, that's the top left. Dimension. Well, dimension is V2 length of collision, V2 sub, I guess, collision line P2. Collision line P1, it doesn't really matter what the order is here. Now we need to figure out if it's vertical or not. Well, vertical means collision line P1, vertical line, so the x is the same. Maybe they should just be collision shapes instead. Just polygons. Okay, well, we're just swapping them, right? Dim y dim becomes dim x, and collision line direct world dim x becomes thickness. also doing a bit of a shift. Because, yeah, we're trying to draw rectangles that collide with a block from right. Well, God. I guess we're just not gonna be doing this for now. Okay, now what do we need? This is really not great. This is not great. And I get, well, yeah, we'll think about how to improve that. Maybe I do just need to do... No, it's just not clear at all what I need to do to make it better. Because at the end of the day, I will be colliding with lines. So at some point we do have to specify lines to collide with. And therefore I do need to be able to draw the lines. Yeah. So what do we need? We need normalize. Static v2 normalize v2 return well whatever it's which is divided by the length, right? So it's v2 scale v by 1 over length. Yeah. 1 over v2 length. The static f32 v2 length v2 return. Well, length squared would be vx v square vx plus square vy and square root. So just that. Square x return x times x and then square root, of course, is something else. Square root x okay, what's the square root intrinsic? Square root square root SS, that one. Yeah, of course we need to load and unload and do the... do we have intrinsics included? No. Include intrin, yeah, that works. So square root is mm we wrote SS. That's like val x 128. Set 1 p s set 1 p set 1. Or is it just set ps? Set 1 p. Oh my god. No, that's all of them. We also set ps1. And there is set 1 ps, which are different. Yeah, so they're actually the same. Alright, well, whatever. What's this? M128, X128 is that. What does this return? It's M128 again. The result 128. And then what is this? MM convert SS F32. The lower is I used extracts a float contained in the lower. Yeah, that is what we want. The res 128 F32 result is that return result. Okay, so something like this. What's wrong with the build? Error while processing. Oh, I see. That's helpful. Yeah. Oh, there's a missing semicolon somewhere. Here. Yeah. Okay, quarter turn. Now I just fix the quarter turn. That would be nice. Quarter turn. Well, static v2, v2, quarter turn v2v, return v2. Okay, so the y becomes the x, but you need to negate it, right? So it can be y and then bx. I think that's all we need there. Oh my god. Quarter xy quarter turn. Just that. Alright. Okay, I don't really know. Oh my god. All sorts of things happened there. Why did we fall? I don't really understand it. If collided or and false. Okay, interesting. So we are falling. Just continuously for unclear reasons. Presumably, is it somewhere in the update? Yes. Okay, so somewhere in the update, we are updating the sprite. Oh wait. Oh. I changed it to be at the bottom right, but then I didn't change it back. So its current position so right here, like current position Y, we need to add back collision dim Y, because we subtracted it, we went down. So now we need to add it back, and then we need to do this change as well. So now at least we're not moving anywhere. Okay, so that there's a wall. We're not colliding with the wall, but it is there, being drawn at least. It might, yeah, so we're colliding with something. It's just not being drawn in the right place. It's certainly colliding with something. And yeah, it should probably be here, like it wasn't here before, so. If P1x is less than, or P1y is less than, then it's P1, otherwise it's P2. It's the top left in the world space. Left. No, it's actually greater than, right? Because it's the top specifically, we're looking for the top. Okay, so I think this is being drawn in the right place at least. Well, kind of. Okay, well, we are colliding with the wall, which is here, although we might be moving it in the wrong direction for the purposes of collision detection. Actually, on the X, like, is it? Yeah, so it does seem to be correct collision. It's just the wall is in the wrong place. So what kind of wall did I even create? Well, P1 is, so the X is the same, it's minus 100. The Y is minus 40 to 40. So minus 40, 40, so it's, just go back here. Minus 40, 40, P1, P2. Okay, so it's this wall, it's the right wall. P1, P2. So we are colliding from the right direction, seemingly. It's just, I seem to have moved the wall here rather than here. We're colliding from the right. P1 minus 40, 40. Minus 40, 40. Yeah, so that's fine. Yes, need to figure that out. And the wall shift. So wall shift has to be negative, and then we just scale the wall normal by that amount, and then we add to both points that wall shift. So there's only one wall, and given that there's only one wall, we should only enter into here once. So what is wall shift? 4. Minus 4. Wall normal is minus 1. Oh. Yeah. Okay, so it flips. We actually want to scale by the absolute value. Yeah, this is not great. This is not great. Okay, maybe I should put it to do here. Too many special conditions. Conditions, branches. There is probably a way to simplify this. Okay. Okay, so where are we now? Okay, so now we're colliding with the right thing. So all I really did was change how the wall is specified. And of course, the old code could still work if I just converted my specification of a wall into this block from left, block from right, situation. Not that that was necessarily much better. I mean, there was less special condition and branches going on. Well, I should probably move this to the right, since it's the right wall. And then have another one on the left. Oh. No, okay. Move back. And then we just switch these around. And it should be blocking from the other way. Here. Yeah, of course it's the left edge of it that's now that when I'm colliding with. Now let's do minus 40. So minus 40 to 40, and then x, y, so that would be bottom. Well, I mean, it does work. For side on, it doesn't work. 40 minus 40 for the top one. And against the top edge that we're colliding with. Interesting. Okay, well, that's something. Okay, this is fairly easy to generate from assets now. Of course, the way we're processing it isn't exactly super easy. But then, like, what would be easier, right? It's like, for the general case, you kind of need to create extra walls. And in our case, that just doesn't make much sense, because one of those walls is just going to be aligned with what we already have. Of course, you could just merge them. Like, you can create the extra walls and then merge them or something as a special case. Or you could just collide with all of them. All three. Except, well, so each wall, I mean, we could transform it into two. Well, could we just do that? And then not have quite so many weird special cases everywhere. Just move by half dim. Yeah, but then again, this would be not prone to special cases, because that just works no matter what, because these are symmetrical. So you just move these points by half dim, no matter where, what the normal is doing, it doesn't matter. Just move by half dim, then create these two extra ones, and then do the symmetrical transform of each of them, which just means what? Well, it means move this one like down to the right, and move this one down and to the right, and move this one down to the right. Yeah. And then just collide with each of these walls, each of these 6 walls, and see what that gives you. Well, I mean, you still kind of need to know what the wall normal is. Well, actually, do you? I mean, if the wall normal was this way, then you would just collide. Well, yeah, I mean, I guess when you're doing the transforms, keep in mind that the direction that you're moving in, like, well, just pay attention to what's going on with the wall normals. And then just collide with each of these walls, and then that'll give you the correct result. Yeah, so if you want to turn each wall into 6 walls, then every wall will be processed the same. each wall needs to remain as one wall, then it's not quite so simple. And we do need to figure out what, like, is it this way that's better, or is it the way that I had it before that's better? Yeah, I don't know. At least we are where we were before. And then this still works. Although now that I've done this, it's not like, it's not exactly obvious that this is even a win over what we used to have. It's like, yeah, the walls are easier to specify in art now. And, well, not just in art, but I mean, I guess they're just easier to specify in general. Like what we had before was 2 numbers plus a number for the length plus an identifier of what kind of wall it is. And now it's 4 numbers. So in terms of the amount of data, it's actually the same. In terms of the amount of data, it is actually the same amount of data. So maybe all of this needs to. Yeah, I'll put it to do here. Go back to point length kind spec. Like maybe that was actually a better specification of a wall than the 2 points, with the order being which kind of wall it is. And this is more general with the same amount of data. Not that we need the generality. Yeah, I don't know. I gotta think about that. Okay. Yeah, I mean, see, the data didn't change, I mean, the amount of it. Used to be an I32, F32, F32, F32. Yeah, it's the same amount of data. That's... Yeah, this needs to be re-enabled probably. And there's, in general, probably a better way to just have 2 points and just draw a rectangle. Well, although this is kind of special, right? Because it's a collision line, so it needs to be drawn in a special way. Encode walls differently. I mean, I guess that's what I did. I encoded walls differently. And that's it. Other than that, it's the same. It's the same thing we had before. if, then, if, then. And add the extension to the bound one. Yeah, okay. Yeah, collision rect's actually the same as, like, the offset in them, it's the same as the art. So I'm guessing it's actually wrong. Anyway, so like if we go to the collision layer and we just remove this, now the collision should be this one point. But like, I don't think that's what it's gonna be. What is it? It is? Does it just work? Oh, no? Maybe. Okay, well, it seems to be just working somehow. Interesting. Somehow it just works. I'm guessing it's because ref point x minus first frame, ref point y minus second frame. Oh, yeah, so we are doing something interesting here. So the reference point x gets subtracted, but the first frame art offset, if that's 20 and this is 25, that ends up being 20 minus 25, which is minus 5. So this ends up being minus 5. So you go down, meaning down by 5. Huh. So, okay. Oh, that's only used here. Oh yeah, because we used to use it in a different place, but now we're only using it here. So we are actually accounting for the bottom up, top down thing. Oh. Okay. Okay, so the collision offset is correct in that you can just add it to the top left in world space. And it just works as expected. Okay, well, if that's the case, then I guess that to do is done. to do. Okay, well, this is gonna be all for today. Thanks everyone.